Hi everyone, this lesson is a review for your chapter test, chapter 4 test that's coming up this week, so let's get started. First question is a warm-up, and the warm-up is saying, is there enough information to conclude that the two triangles are congruent? If so, what postulate would you use? So I'm assuming they're talking about ABC and ACD, these two triangles here. To prove these two triangles are congruent, you need 3 parts of one triangle congruent to 3 parts of the other. I know that these are parallel, which would then give me alternate interior angles. So I could say, because this line is parallel to this, so because AD is parallel to BC, we know this angle here is congruent to this angle here, okay? Because AB is parallel to CD, we know that this angle here is congruent to this angle here. We also know that AC is congruent to itself by reflexive property. So yes, these would be congruent, the two triangles would be congruent by angle, side angle. For this one right here, we know that these two lines are parallel, which would mean that this angle is congruent to this angle, and this angle here would be congruent to this angle here. We also know that this angle in between here, those are vertical angles, are also congruent. These two triangles are not congruent because they're not congruent because you need at least one side to have two triangles congruent to each other, okay? Not just 3 angles. Naming the corresponding parts to these triangles, well, let's go with it this way. We know that we know that angle ACD is congruent to angle ACD. We know CAB. We know that angle DAC, so angle DAC, is congruent to angle BCA. We know that angle B is congruent to angle D. And you can use one letter when you don't have multiple angles around. We know that AC is congruent to itself. AC. We know that AD is congruent to CB. And lastly, we know that AB is congruent to CD. Okay. For this one, this is definitions review. We did this the last day we had class. The points of concurrency is what they're asking me what it is. You have an angle bisector. An angle bisector starts at the vertex and connects to a side. It divides that angle into 2 congruent parts, or 2 congruent angles, and 3 angle bisectors. 3 angle bisectors make what's called an incenter, and then something where if you have that, you can inscribe a circle within. 3 medians. A median of a triangle is a segment that goes to the midpoint of the opposite side. So you would have drawn a perpendicular bisector first to connect to that midpoint. 3 medians connect and they make what's called a centroid. Okay. Then you had altitudes. 3 altitudes make an orthocenter, and 3 perpendicular bisectors make what's called a circumcenter. And just keep in mind something that we talked about in the last lesson. If I have 3 of these like this, oops, let's see here, 3 perpendicular bisectors, here, and then let's say there's that one right there. They do intersect in one point. That point is the point of concurrency called the circumcenter. 3 altitudes can intersect. Altitudes, remember, is always the height that intersects into an orthocenter. However, keep in mind, again, that if it was an obtuse triangle, and I did extend my sides, there's an altitude, here's an altitude, and if I extend this side, I would also have an altitude here, okay? And those altitudes are actually intersecting outside of my triangle, and those are called the orthocenter. They have two theorems here. We have the angle bisector of an angle is a line or ray segment from the vertex that cuts the angle into two congruent angles. The theorem about the angle bisectors in a triangle is that if a point lies on the angle bisector, so if it lies on any part of this bisector, it is equidistant from those sides. So if it was here, then you could say, well, there we go. It's equidistant from there to there. It's equidistant from here to here. Okay, so it's going to be the same distance. Likewise, on a perpendicular bisector, any place on the perpendicular bisector, if the point lies on the perpendicular bisector, then it is equidistant from both of the endpoints, no matter where you're at. Okay, so those are both congruent. Deciding whether these two triangles are congruent, in order to see if something is congruent to something else, you would need to say, let's say, BOW. Okay, you're trying to say BOW is congruent to, see how we started off B and then we went up there? We would start off at T and go up to I, so that would be T and then I and then B. If they are congruent, let's see what we know. We know that BE is, we know this little part here is congruent to this part here. Because this is congruent to itself, that would make this segment here congruent to this segment here. Okay. Additionally, we know that these little angles are congruent. So for me, I'm not sure if this is something that you like to do or not, but it is something that I like to do. So I'm going to share that with you. So for me, I like to draw over my triangles. So I have this right here. Okay. And I'm going to draw over this one here. And I know it's a lot harder to do on a piece of paper, but if you would just redraw them on the side, see, like that. And so now it's a little bit easier to see what you're talking about. We know this side is congruent to that side. We know this angle here, see that angle right here, is congruent to this angle right here. We also know that this segment here is congruent to this segment, so we do know this is congruent to this. If that's all the information that I have, I could not say that these two triangles are congruent, because then it would be side-side angle or angle side-side, which is not congruent. So if that's the only piece of information I have, which it looks like it's a side, and an angle, then I would say these are not congruent, okay? Because you can't prove that they're congruent by side-side angle. Let's look at this one right here. It says RV. So we know that RV, and again, I'm going to draw my triangles and I'm going to separate them. Okay, and then I'm going to draw this triangle right here. And so when I draw my two triangles and I separate them, this is what I see. I see that RV, so RV is this side that came down here. That's congruent to TU, which is this side. We know that these end angles, this angle here, is congruent to this angle here. We also know, we know the angle U is congruent to angle V. Okay. Now, aside from that, we also are using the same angle up here. Angle A, or S, I think that's an S, is congruent to itself. So this would be angle, angle, side. So you would say this is angle, angle, side. And yes, they're congruent. You would say SUT is congruent to SVR. So triangle SVR. Okay. So for the next triangle, let me go back here. So for the next triangle, it's a little bit hard to see. We know that these two triangles, see that side's congruent to itself. The two triangles are congruent pretty easily by side, side, side. And therefore RAT, so RAT is congruent to BAT. So triangle BAT. For this one, we are looking at triangle A, let's see, it looks like ABD. I can't see that actually. So let me get a little bit closer to that. And that says AEB. Thank you. Okay, so we are looking at AEB. So we're looking at that triangle, and we're looking at this triangle here. So for those two triangles to be congruent, what do we see? Okay, let me move that here. We know that AE, so we know a side is congruent to a side. We know a side is congruent to a side, and we actually know that these are vertical angles, so therefore, vertical angle theorem, this is congruent by, the two triangles are congruent by side angle side, and therefore, you would say AEB is congruent to triangle DEC. More of the same. We know that, let's see, this side is congruent to itself. Okay, now here's the thing with this. The last triangle that we said was not congruent because of side-side angle did not have a right triangle in it, a right angle in it, whereas this one does. And even though you wouldn't say these two triangles are congruent by side-side angle, the fact that it does have a right angle would mean I can use what's called HL, hypotenuse. There's my hypotenuse and leg. So these would be congruent by hypotenuse leg, and you would say ABC is congruent to triangle ADC. So ADC. For this one, this is angle side-side, negative. This would be a no. For this one, I feel like I just did this one. I did. That's a side-side-side. PT bisects QPR. So PT bisects. So that means it cuts it into two equal parts. Separately, we want to know what PTQ is. So they're looking for this angle right here. What I see is the big triangle, and I see that that's an isosceles triangle, and I see that that must be 72 degrees, okay? And we know that 72 and 72 is 144 degrees, right? So therefore, if I subtract 144 from 80, right, 8, 7, I'm going to get 36 degrees, which means this angle in here is 36, which would mean this little angle in here is 18. So if I take 72 and I add 18, okay, I'm going to get 90 degrees. So these two make 90 degrees, which would mean that this would have to be a 90-degree angle. Okay, so now we have angle TAP. So we have TAP, and if I just say that's T, and then here's A, and here's P. AT is congruent to AP. Angle P is X, and angle A is 8 x's. Find x. Well, we know this is x. Well, this has to be x, because remember, for an isosceles triangle, if you have one side congruent, two sides congruent in a triangle, it makes it isosceles, of course, but also that the base angles are also congruent. 8, 9, 10, so a total of 10 x's is equal to 180 degrees. So if I divide both sides by 10, I'm going to get x is equal to 18. Next question says, angle 1 is 68. So down here is 68 degrees. And they are asking me to find all of the angles. So if we know that's 68, we also know this is 68 here, okay? So 180, well, let's do this. 68 times 2, because that's both of those, right? 16. That's 136. 136 from 180, 136 from 180 is 44, and so therefore angle 2 is 44, okay? Which would mean, because these are both parallel lines, that would make this 136 degrees as well. And if I take 180 and I subtract 36 again, that's 44, which, breaking those down, because these are isosceles, it's an isosceles triangle, would be 22. And then lastly, this right here is a straight line. So if I add 68 plus 22, 0, 1, 6, 7, 8, 9, I get 90, which would mean this angle is 90, because that would make that 180 degrees. An obtuse triangle and an acute triangle are never congruent. Two equilateral triangles are sometimes congruent. In ABC congruent to DEF, A is always going to be congruent to D. ABC congruent to DEF, I would say A is going to be sometimes congruent to E if, let's say, it was isosceles or it was equilateral. A right triangle and an isosceles triangle are congruent in isosceles triangle. So we have a right triangle. Okay, a right triangle can never be congruent to an isosceles triangle, because once an isosceles triangle gets a right angle, then it can never be an isosceles triangle again. It'll be a right triangle. So here's a proof. We are given that MK is congruent to NK. We are given that ML is congruent to NL. And you are trying to prove that MJK, this angle down here, is congruent to this angle here. Okay. What I'm looking at is this triangle here, this big triangle like that, and I'm looking at that being congruent to this triangle down here, because once the big triangles are congruent, then all the parts are congruent. So if I take this apart like this, what I know is this side's congruent to this side. I do know this side is going to equal to itself because it's the same length. Now, if I can prove that this triangle here is congruent to this triangle here, then, and they are, because that's going to be side, 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 right? Side, side, side. Then the parts are congruent, and I can say this angle is congruent to this angle. And if I said that that angle is congruent to that angle, that would mean the two triangles are congruent by side angle side. And if the two triangles are congruent by side angle side, then I can then say this part of the triangle is congruent to that part of the triangle. Okay, so I would pause the video and write all that out, make sure that you can write that out, and then move forward to make sure that you have that correct. We already did this in a previous slide, so would behoove you to go back to the previous video to complete that. A quick check, what would this line be that connects to this this bisector? That would be a median. This would not be an altitude, because altitudes go from the vertex, like this. This would be an altitude. This looks like it's a perpendicular bisector. Okay. Another proof. Let's look at this one. We have XY congruent to XZ. Well, what does that tell you? Right off the bat, that tells us that angle 3 is going to be equal to angle 4 because of the isosceles triangle theorem, ITT. So we also know that 4 is congruent to angle 5, vertical angle theorem. So not only do we know that 3 equals 4, but 4 equals 5. If 3 equals 4 and 4 equals 5, then 3 also equals 5. And therefore, I don't even have to prove, I'm not proving even any two triangles congruent. I'm just proving by the transitive property that those are congruent. So in saying all that, number one, you would say the given. So you'd say XY is congruent to XZ, and that is by given. Based on that one thing you now know that angle 3 is congruent to angle 4, and that would be the isosceles triangle theorem, ITT. Number 3, you can then say that angle 4 is congruent to angle 5, and that is vertical angle theorem. And lastly, you could say that if these two angles are the same, I can say that angle 3 is congruent to angle 5, and that's based on the transitive property of congruence. So transitive property of congruence. We have find the value of x again. Oh, I know. This is x, right? It's a right triangle. So these two x's have to add up to be 90 degrees, right? So 2x is equal 90, and so x is equal to 45. For this one, we know that the angles are congruent. So by the converse of the isosceles triangle theorem, that means the two sides are congruent. So I can say that 5x minus 8 is equal to 2x plus 7. We have 3x equals 15, x equals 5. If they had asked me to find the lengths of the sides, right, I would just plug that in. 2 times 5 is 10, 10 plus 7 is 17, and then 5 times 5 is 25, 25 minus 8, also 17. For this problem, let's see, we know that these two angles are congruent. we know that if these two angles are congruent, that means the angles are congruent. If the two sides are congruent, the angles are congruent. We do not have this information here, whereas if this is 90 minus x, and this is 2x, so this must be unknown. We don't know what this is. So actually for this problem right here, we don't have enough information. You need one more piece of information, because I would have known this had they been all the same length. That is equal to that is equal to that. And then let's say these were all 60. Then you could find that. But for this problem, I actually don't have enough information. So that's all the information I have for you for today. So good luck on your Chapter 4 test. Please come in if you have any additional questions, and I will see you on Wednesday. All right, thanks for watching.